Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome to Derivatives, the Chain Rule. Now, this rule is one to lose sight of very easily because there are so many moving parts to it. So we have to really be careful with it. So we're going to kind of develop it a little bit slow so that you guys can see. So right now, if I were to give you a function, let's say 3x cubed plus 5 to the second power, and I were to ask you to find the derivative. Well, first you would have to change this to 9x to the 6th plus 30x to the 3rd plus 25. Then you could derive it, and we'd get 54x to the 5th plus 90x squared, or factored, we would get 18x squared, and we get 3x cubed plus 5. So what you might notice is that the 3x cubed plus 5 and the 3x cubed plus 5 is still there, except instead of the second power is now the first power. You might also notice that the derivative of what I've highlighted in pink is 9x squared. But if I were to have taken that by the exponent, I would have gotten 18x squared. That's actually kind of what the chain rule does, okay? So if you're going to derive f of g of x, notice how g is inside of f. So I'm going to go ahead and highlight this because it's outside. So what's going to happen is to derive that, we're going to have the derivative of f, keeping g inside, and you're going to multiply that by the derivative of g. So this is what happens when we have a composition of a function inside of a function. Now, we could have very long chains. You can have functions inside functions, inside functions, inside functions, which is why you have to be very careful with the chain rule. But the nice thing is when we do it, it takes it straight to a factorable form. So again, from up above, f prime would be 2 times the g function, drop the power 1 because we use the power rule, multiplied by the derivative of what's inside, and that's how we get the 18x squared, 3x cubed plus 5. Now, there are certain functions that I've done in my previous video that you might go, well, we didn't do the chain rule on them. And you're right, we didn't, but I also only gave you ones that could be done as such. For example, f of x equals the sine of 6x. Before, I only gave you a single x. I never gave you 6x. I only gave you x. This is what I've given you before. And this is on the inside, and the derivative of x is 1. So technically, we really were doing the chain rule all along. We just were not. Timesing by 1 is nothing, right? So we need to keep in mind that this is really the sine function with a linear function inside. So when I go to derive it, I have to derive the purple first. So the derivative of sine is cosine, keeping the inside the same. Then I can multiply that by the derivative of 6x, which is just 6. So 6 cosine of 6x. Sometimes I write my trig words in cursive. That way they're all stuck together and I can read my writing. Okay, so one of them that I started to put on one day, and then I was just describing how functions related, and I didn't actually finish it, was something similar to this. So we have a quadratic inside a radical. So I'm going to rewrite that. The radical is a 1/2 power. What's inside of it is 3x squared minus x plus 1. So now I'm going to go derive it, the derivative. We take care of the purple on the outside first, so 1/2. And now subtract 1. And we're going to multiply it by the derivative of the inside, which is 6x minus 1. So I'm going to rewrite that a little bit prettier. 6x minus 1 would be the quantity in the numerator. And we'd have 3x squared minus x plus 1. Now, all those years that your algebra teacher spent making you rationalize and fix the denominator, unless it's a numerical answer, we generally don't do that in calculus. So we're not going to do that with equations because what we're going to be doing with them changes. All right, so let's move it up a notch. Okay. F of x equals sine squared 4x plus 3. Okay, so it may not look like it's moved up a notch, but let's really think about what's going on here. We have the squared part. We have the sine part. And we have the linear part. So we actually have to chain this even more. Okay? All right, so we're going to start at the outside and work our way in. So deriving the squared. 2, keep the entire parentheses the same to the first. So sine 4x plus 3. Now I can derive sine. The derivative of sine is cosine. So I derived the purple, now I've derived the blue, now I'm going to derive the brown. The derivative of 4x plus 3 is 4. So if I were to rewrite this, I would write 8 sine of 4x plus 3 cosine of 4x plus 3. In my classroom, I would accept this answer. Okay? However, some textbooks might think, oh, you need to simplify this even more. We have a rule that says the sine of 2x equals 2 sine of x cosine of x. So see right here how we had 2 sine cosine? And then times 4. So they might write instead of 4x plus 3, times it by 2, 8x plus 6. So if you haven't used double angles before, you might go back and refresh your trig. These are equivalent answers. I would accept either in my classroom. The reason why I'm giving you the option there is because of a difference in the books. So I don't know which textbook you're going to get and which answer key it might want, so I just want to let you know that sometimes things are equivalent. Now, your book's not just going to let you off the hook with just doing a few chains. You're going to have to identify when there's a rule that you use versus a chain that you use and how they all get mixed together. So we have to really understand that. So let's let f of x equal and we're going to find the derivative. Okay, well, what can we do? Well, the first thing to notice is that this is x to the second being multiplied by 1 minus x squared to the 1/2. And you'll find that I always use rational exponents when I can, working through a problem. Okay, so that big times, that's a product sign, right? So because of that right there, we have a product rule. That's just x to a power, so we can use our polynomial check on that. But this is a quantity to a power, so this right here means chain rule. Okay, so product rule, I don't like to think of it as the rule itself. I like to think of it as first times derivative of the second plus second multiplied by derivative of the first. And I like to write it that way. That way I have more space. So first, that's the x squared, multiplied. The derivative of the second, that's that chain rule, so 1/2, 1 minus x squared to the negative 1/2, because I did the power. Now I'm going to multiply by the derivative of the inside. Okay, so this whole thing was the derivative of the second. Plus the second multiplied by the derivative of the first. And the good news is if you mess up the order, because it's a sum, you're okay. Product rule, you can mess up the order because products are commutative. Quotient rule, we cannot. All right, let's clean this up a little bit. So if I multiply these three things together right here, I would get negative x cubed. This has a negative exponent, so I'm going to take it to the denominator. Plus 2x square root, like that. So that could be one option for an answer. It is a binomial. You could choose to give it a common denominator. You could leave it right there. It depends on what the question is asking. Depends on what the book is asking. You could give it a common denominator. Which would give you negative x cubed plus 2x times 1 minus x squared all over the square root of 1 minus x squared. Which would be negative x to the third plus 2x minus 2x to the third. Or negative 3x cubed plus 2x and then I'll erase where I wrote in the work here. That way we can compare the answers. Just that step. Okay, so you could leave your answer as purple, which not a bad answer. This is a much cleaner answer and could be what you find in your textbook if you're checking the back of the book. There is a lot of reasons that we might want to go for this, especially if we're trying to apply derivatives. But since this is your initial run in deriving, you may not want to go this far. So again, it depends on your end goal. Okay, so I've had this up in rules to know before. I want to add reminders of a couple. So the derivative of any base to the x power, I've had this in a previous video, I just forgot to write it on here, is going to be your base to your x power times the natural log of your base, which therefore when you do that to e, the natural log of e is 1, so that's why the derivative is just e to the x. So wanted to refresh the memory of that because I'm getting ready to do an example with that. And then the derivative for f of g of x is f of g of x multiplied by the derivative. So these are definitely rules to know, and I'll just keep adding on. The derivative of a sine is cosine, and the derivative of cosine is negative sine. So if you're a flashcards person trying to prep for, a deriving test, these are ones that I think are just kind of gimmies. You should just know those. without a doubt, hands down, you should just know. So if you need to, freeze the screen, make yourself some note cards, something to that effect, and keep them somewhere so that you refer to them, but make sure that every day you're referring to them less. Okay, so where is that going to come into play? Well, let's think about this. What if g of x equaled 8x cubed minus 5x? Oh, come on, stop being blurry. Okay, well, that means that we're going to have to, one, get it unblurry. Some days I like my camera better than others. Maybe it wants light. There we go. Now it's happy. So what we're going to have to look at here is we're going to notice that we have a base to a power with the exponent. So that's going to be that special rule where we have to do the base to the power multiplied by the natural log of 8. However, we didn't just have 8 to the x, we had 8 to a complicated thing. So that means this right here is an equation that's been put inside the 8 to the x equation. So now we have to multiply by the derivative of that. So make sure that you're chaining everything together correctly. Now, this is written as a product, so it's in factored form. I happen to like this form. Do I care which order the multipliers are in? Not necessarily. Just make sure you're really careful with recognizing if a rule doesn't have something complicated inside of it. So if you'll notice, every single one of these rules just has an x inside of it. Not an x squared, not an x plus 5, just an x. So if there's something more complicated inside parentheses technically, then you're going to have to chain it. And even though I did not write parentheses around the exponent here, they were understood, and therefore in comes the chain rule.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.